Hi guys, in this video we're going to be talking about the reaction quotient, or Q. So here's the equation that you're given, where little a is the coefficient and big A is the thing you're using for the concentration, or your reactants and your products. So the reaction quotient is basically calculated the same way as K, or equilibrium constant, but it's when the system is not at equilibrium or just a random point in time when the reaction's taking place. So you're going to do the same thing. Well, QC, we're using, for example, when you're using concentration, but you can also use partial pressure, like I talked about in the last video. You do the concentration of C to the power of the coefficient, and then the concentration of D to the power of the other coefficient over the reactants. And so now we need to use Q. We interpret Q and K to determine where the shift is, where the reaction is at that point in time. So if Q is less than K, the system is not at equilibrium, clearly, and it would be a shift to the products, because since Q is less than K, there's more reactants than there are products. So that means that it has to shift to produce more products to compensate for that overtake of reactants. When Q is equal to K, the system is at equilibrium. So the concentration of the reactants is equal to the concentration of the products. And when Q is greater than K, the system is also not at equilibrium, but there's a shift to the reactants because you have more products and you need to get the same you need to keep the concentration constant. So you need to shift to the reactants in order for that to compensate for the amount of products. So I hope that helped with Q and K. When in doubt, you can memorize these, but you can always just think it through using this simple equation. And I hope that helped. Thank you.